now I've got this little calorimeter to where I can take and cut another video and show you what the next process is going to be. I decided to use the two glass thermometers. There is a slight difference in them. You can see that one has a greater diameter than the other. That's this one here. The reason for that is I may want to be able to take this out. These read only in 1 degree centigrade, and you can interpolate down to a half. But I do have one that I can put in here that reads 10th degree. So I may eventually take and change this one out. That's why you see those differences. Mounted the terminal strips for the power, brought the pigtails out, sealed everything up. You can see the sealing down here so that I don't have a lot of copper wire or practically any copper wire hanging around in there. Did the same thing on this side. And what you're going to see here is temporarily what I'm going to do is I've hooked a 10K ohm resistor that is actually just a tish over 10K by 22 ohms. And what you want to do is you need to find out how sensitive your unit's going to be. And the way I'm going to do this is apply 1 volt DC to this resistor, this 10K resistor, which will give me 100 microwatts, and watch it for an hour and see if my unit will be sensitive to that and what type of reading I have after the hour. I decided to initially start out with this synthetic fiber on the front of the lid, and then I've made a rather crude clamp here, which I'll take and go ahead and put it on and then come back and show you how it's all assembled. Okay, as you can see, I didn't get involved too much in beauty. I wanted to try to do it so someone could duplicate it without having specialized tools or something. So I have a piece of wood in the back, 2 long bolts, piece of wood in the front, and basically you can see that it just clamps that door on the front of it. And one of the things you want to remember while I think of it, because I may forget it later on, but whenever you put anything into a chamber, when you touch a device or a board or something like that and you're going to put it in there, what you want to do is let it reach equilibrium with the ambient temperature before you put this door on. That way you're not going to add heat to the components, put it in there, and then have to wait for it to cool down or start from an irrelevant point. So anyway, this one's actually ready to test, and I'm going to go ahead and hook it up to 1 volt DC from a decently regulated power supply, and I'm going to let it run for an hour and see what actually transpires as far as my temperature increase, and see if this is going to be sensitive to 100 microwatts. If it is, then I'll take and put in a 100K resistor and go down and see if I can get sensitivity to 10 microwatts. If I don't see anything here, I'm going to go to 1K resistor and see how it does at 1 milliwatt. So anyway, I'll report back, but there's basically how this dual cell calorimeter is going to look. And like I say, right now what I have is a 10K resistor in here with 1 volt. Going to run it for an hour and see just if this thing's going to produce anything at 100 microwatts.